Okay, so I know we all love our division of polynomials, and so I might show you, I guess the key thing to take it, very rarely will we ever have to do a polynomial like these and divide them, okay? I think our repeated factor method is the method that a lot of us like to use, or even that synthetic division. So it's worth Googling synthetic division and just have a look at that, because that is a nice, very non-mathematical way of doing the division and making sure you get the right answer. So if we have to do the division, let's do x minus 2 into 2x cubed minus 7x squared plus 15x minus 3. Okay, so the first things first is, what do I multiply x by to get 2x cubed? And that's 2x squared. So 2x squared times x is 2x cubed. 2x squared times negative 2 is minus 4x squared. We then subtract off. So that should get to 0 if we've done it right. We've got to be careful of negative signs. Negative 7 minus, a minus is plus. So that's negative 3x squared, and I'll bring that 15x down, which is the next term. Okay, so then the next thing I need to do is, what do I multiply this x by to get this negative 3x squared, and that's minus 3x. So negative 3x times x is negative 3x squared. Negative 3x times negative 2 is positive 6x. Again, we subtract off. If I've done it correct, I get 0. 15x minus 6x is 9x. Bring the negative 3 down. So again, what do I multiply this x by to get that 9x? And that's 9. So I get 9x, 9 times negative 2 is negative 18. Subtract off again. Minus 3 minus a minus is plus, so negative 3 plus 18 is positive 15. So what we say is, our, the divisor, our Q of x, the quotient, is given by 2x squared minus 3x plus 9, and my remainder is 15, and that's yet to be divided by x minus 2. So if you remember from last year, often the remainder was 0. So if I want to use the repeated factor method, if I've got enough room, I write the factor down 3 times, x minus 2, x minus 2, x minus 2, and what I'm looking for, same sort of thing, what do I multiply that x by to get? So my original graph or function, 2x cubed minus 7x squared plus 15x minus 3. So I've got to multiply that by 2x to get 2x squared to get 2x cubed. So if I expand that bracket, I get 2x cubed minus 4x squared. I've got minus 4x squared. I meant to have negative 7x squared, so I need to increase by another 3x squared. So if I multiply by negative 3x, I'll end up, if I expand that bracket, negative 3x squared plus 6x. I've got 6x. I'm meant to have 15x, so I need to add 9. So if I expand that bracket, I get to add another 9x, and I have minus 18. So I've got minus 18. I'm meant to have negative 3, so I have to add 15. Okay, so I've got to add 15, and so that makes that my remainder. All right, so you can see there, I've got 2x squared. If I bring down the numbers in red, 2x squared minus 3x plus 9 with the remainder of 15, which is again that 15 over x minus 2. Okay. Oh, going to run out of battery, guys. So if I very quickly do my division if I want. So let's just rub that out. that line in the middle. So again, what if I give my repeater factor? I'll do it 4 times because there's 4 x to the power of 4. So first things first, to end up with 3x to the 4, I've got to multiply by 3x cubed. I'm going to take the x out, doesn't matter. 3x cubed times x, 3x to the 4, 3x cubed times negative 4 is minus 12x cubed. I've got negative 12x cubed, I've got no x cubes there, so I'll have to add 12x cubed. So if I add 12x squared times x is plus 12x cubed. 12x squared times negative 4 is negative 48x squared. I've got negative 48x squared. I meant to only have negative 9x squared, so I've got to add 39x squared. So a 39x out the front, multiply through, I get plus 39x squared. Negative 4 times 39 is, all 4 of them is 160, so it's going to be a 156. 156x, I meant to have 27x. So how much is that I got to add? Sheesh. Is that 129? I hope. It's plus 129x. Oh, that's right. Geez, that's a big number. 4 129s, 130s is 520. That's 4 is a minus 516. I meant to have 0, so that means I've got 516 remainder. So after my division, if I get all the red terms out, I'll get 3x cubed plus 12x squared plus 39x plus 129 with a remainder of 516. What a messy equation. Okay, so let's come back to the synthetic division and I'll just show you another little way. You can certainly Google this and you can see it on Khan Academy and things like that. So synthetic division involves us writing down the coefficients of the polynomial that we're going to divide by. So 2, negative 7, divide into negative 3. And the number we're going to divide by x minus 2, so we put a plus 2 out the front. Okay? First step is always bring down the leading term, which is a 2. And all we simply do then, 2 times 2 is 4. Add them together, I get negative 3. 2 times negative 3 is negative 6. Add them together, I get 9. 2 times 9 is 18. Add them together, I get 15. So what these numbers tell me is that my resultant quadratic is 2x squared minus 3x plus 9 with a remainder of 15, which, if we sort of go over here, is the same result. So certainly this is simpler in so many ways and there's less formulas and rules to worry about. The only thing is it only works if we're just dividing by an x plus 2, an x minus 2, an x plus 6, x minus 6, that sort of thing. But certainly it's something worth looking up to see how you go with that. Okay, so if you recall from also, let's come back down there to our remainder theorem. When our polynomial is divided by some factor ax plus b, the remainder is negative b on a. And that leads us to how we find that first solution for factorising. So I guess another application of this, if x cubed plus 2x squared plus 3x plus p have the same remainder when divided by x plus 2, find p. So straight away, let's go to that polynomial there. And if we're going to divide by x plus 2, we put in p of minus 2. That's equal to negative 2 cubed plus negative 2 squared plus 9, negative 8 plus 4 plus 9, so it's 13 minus 8, which is equal to 5. So that's my remainder, which is going to be the same as if I substituted into the second polynomial. Negative 2 cubed plus 2 times negative 2 squared plus 3 times negative 2 plus p. Negative 8, negative 2 squared is 4 plus 8 minus 6 plus p. So that's just equal to p minus 6, and that's equal to 5. So since p minus 6 has to equal 5, p is equal to 11. All right, so that remainder theorem leads us to our factor theorem. So if x minus a is a factor of p of x, and then clearly, if you divide by a factor, there's zero remainder, which means p of a is equal to 0. And then obviously if p of a is 0, then x minus a is also a factor. So if I want to show that x plus 1 is a factor, that implies then if it's a factor, p of negative 1 has to be equal to 0. So p of minus 1 is equal to negative 1 cubed, minus 4 times negative 1 squared, minus 1 plus 6. Negative 1 minus 4 minus 1 plus 6 is equal to 0. Therefore, x plus 1 is a factor. Find the values of a and b. Find the values of a and b that make 2x cubed blah, 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 exactly divisible by x squared minus x plus 6. So x squared minus x plus 6 has to be divisible. It has to divide into that particular function. If we consider x squared minus x plus 6 is equal to x minus 3 x plus 2. Therefore, p of 3 and p of minus 2 both equal 0. So that needs to be true for the first polynomial. So p of 3 is equal to 2 times 3 cubed minus a times 3 squared minus 13 times 3 plus b. 3 cubed is 27, so it's 54 minus 9a minus 39 plus b. That has to be 0. So what if we just call it negative 9a plus b is equal to, well, 54 minus 39 is 15, negative 15. Call that equation 1. P of negative 2 also has to equal 0. So 2 times negative 2 cubed minus a times negative 2 squared, 13 times negative 2 plus b. That's equal to negative 2 cubed is negative 8, negative 16, minus 4a plus 26 plus b. That also has to equal 0. So I get negative 4a plus b equals negative 16 plus 26 is 10, negative 10, so that's equation 2. Let's put our equations near each other. Negative 9a plus b equals negative 15. So what if we subtract the two equations? Who cares which way we do? We'll go top minus bottom. Negative 4a minus 9a is plus 9a, so that's equal to 5a. b minus b is 0. Minus 10 minus 15 is negative 10 plus 15, which is equal to 5. Therefore, a is equal to 1. And if a is equal to 1, substitute into one of them, I might go back into that one. We end up with, what do we end up with? We'll end up with negative 4 times 1 plus b equals negative 10. So b is equal to, take that positive 4, negative 6. So that means my function, if I come over here, is going to be given by 2x cubed minus x squared minus 13x minus 6. Now, to show that to find the other factor, I'm going to need to divide by this expression here. But what I have just noticed that if I look at my two factors here, if I expand those two original factors when I factorised, it's x squared minus 3x plus 2x minus 6. So in actual fact, that positive 6 sign is a bit of a typo. That's meant to be negative 6. Okay? So those of you that picked up the little error in here, you were right, but that's a mistake in the notes as opposed to, well, I still made a mistake, boys, but it was a good mistake. So we've got to now do our division. And what divides into that is x squared minus x minus 6. So let's just swap colours. So what do I multiply 2x cubed by, or x squared by, to get 2x cubed? It's 2x, or 2x. So 2x times x squared is 2x cubed. 2x times negative x is negative 2x squared. 2x times negative 6 is negative 12x. If I subtract them, I get 0. Minus x minus minus is a plus, so x squared. Negative 13 minus a minus is a plus, minus x, and I got minus 6. So what do I multiply x squared by to get x squared? It's just plus 1. And that leaves me with an x squared minus x minus 6, which is 0. So my other factor is 2x plus 1. Okay, so we got there eventually, but yeah, just note that little error there. Sums and differences of cubes, really, look, very rarely are they on a technology free. They're just something to be aware of. So we can rewrite this as x cubed minus, well, that's 10y all cubed. And the expansion of that, it's just x minus 10y because it's a minus within. And then it's just times the first term squared. And then we just multiply the two terms together. So because it's a negative out the front, I put a plus inside, and then it's plus the last term squared, which is 100y squared. So that's what that expands to. So what are we going to do with this next term here? So running out of room, let's go to a different colour. So in here, let's partition it off a little bit, eh? So if I take 2 out the front, I get x plus 6 all cubed plus 8 cubed. Oops, sorry, plus 8, which is 2 outside of x plus 6 all cubed plus 2 cubed. So there's my sum of cubes, which is 2 outside of x plus 6 plus 2. So I'm just going to take some shortcut. 6 plus 2 is 8 times first term squared, which is x plus 6 squared, minus, multiply the terms together, 2 times x plus 6, plus the last term squared, which is 2 squared. So by rights, 2 x plus 8, expand, x squared plus 12x plus 36, x bracket, minus 2x minus 12 plus 4, which is 2 times x plus 8. What do we got? Plus 12x, let's get out of there, plus 12x minus 2x is plus 10x, so I've got an x squared plus 10x. 36 minus 12 is 24, plus 4 is 28. So they factorise by chance. We've got 14 by 2, 7 4s. What are 4 6s there? 24. So I don't think that factorises, so we can leave it as that form as my factors.